So there is a simple analogy here. And so procedure-oriented programming, as you might all know, procedures are nothing but the functions, right? So there are a couple of names that we use for functions. One is procedures, the other one is functions. And in this class or in this course, we'll be using the term called method. But all these are synonymous to each other. So we mean the same. So method is same as function, which is same as procedure. Okay, there might be some minor differences, but at least for the sake of the course, we'll all treat them, we'll be treating all these three as the same. And like the other point is, like you can see here at the end, so we'll all be using the same slides. So me and Vivek would be using the same slides. And of course, the syllabus would be the same for both section A and section B. Right? And as well as the quiz and assignment. So everything would be the same. Just the people who are teaching that these two sections would be different. Right? Okay. So in function style programming languages, where you have to write the entire code in terms of functions, right? So given a task for you, so you can divide the task into subtasks, and most likely each of these subtasks would be a function in procedure-oriented programming. But the problem here would be there's no way to categorize them together or put them together. So you cannot say that say function 1, 5, and 6 are related to each other. So I put them together in say one box or one piece. So in that sense, okay, you will have files. You can split the functions into multiple files and then categorize them. But there is no way to say what is the relationship, how are they grouped together. So for example, you cannot say function 1, 3, and 5 are related to car or say faculty, or function 2, 4, and 6 are related to the student part. So they deal with everything that's related to the student. If we take the university example.
Sorry to interrupt.
Yeah.
Can you please be a bit louder? A lot of students have commented in the chat.
Oh yeah. Oh, sorry, I can't see the chat.
Yeah, that's right.
Yeah, that's right. Yeah, there are too many things that are going on. So how is my voice now? Is it still low, or is it good, or do I need to be louder? One of you can unmute and let me know.
Yes, it's fine,
sir.
Yeah.
Okay, great. Okay, yeah, thank you. Okay, so I'll try to be a bit loud, and in case if you find any issues, then please unmute yourself and let me know the issue, right? Okay, so there are advantages and disadvantages with this online mode. So one definite advantage is, at least when I compare to the IP lecture, right? Students who are sitting in the back rows, they most likely would not be asking questions, or it would be hard to hear them. Right, like because there is no mic facility, so you would have to shout from the back bench, and they still may not be able to hear it when I stand on the podium, right? But here there is no such problem. Everyone is on, as they say, level playing field, right? So anyone can unmute yourself and ask the question. So that's the advantage, but the disadvantages are that yeah, we can't interact with each other in person. So if you have any questions on the lecture, so I can either, so most likely I can come a bit earlier, so we can start, let's say, at 2:20 or 2:15, and I can be online 15 minutes earlier, and if you have any questions, either from the last lecture or labs or assignments or whatever, you can ask me those questions, right? So you can put it up on the classroom. Or you can include it in the survey. So there's one column, one field, which is general enough. So you can put in any sessions that you want. And in those sessions, you can put in about this, like whether you want me to start 15 minutes early. Not the lectures, but I'll be online, right? Okay, so let me get back to the lectures. So that's about the procedures-oriented programming. So there's no way to categorize or group them together, and that's why if you have, let's say, 50 functions, so it becomes already unmanageable. Right? You don't know, it becomes hard to maintain it or to make changes to it and so on. So that's one of the advantages of object-oriented programming, which we'll look at it throughout the course. So think of this course as focusing on object-oriented programming with the programming language being Java rather than the other way around. So we are not trying to learn Java and learn a bit of object-oriented programming, but it's the other way around, right? Uh, so in object-oriented programming, you can categorize all the methods and then the entire tasks into subtasks pretty well. And the categorization happens through these what are called as classes and objects. So we'll get to know the difference later on in this lecture. Okay, okay, so I'll move on. Okay, so an analogy for object-oriented programming could be a building, right? A building or an apartment. So let's say if you look at it from the top level, and a society, or let's say even trade, so an organization might have multiple buildings, and within each building there are different rooms. Or if you take a housing society, then within each building there are multiple apartments. Right? So as you go down at a final level, you will be seeing these demarcations. So at a high level, a building would have multiple apartments. That's one way to categorize it. And each apartment would have multiple rooms, right? And there will be people sitting in each of these rooms. So if you want to communicate, so let's say it's your house, and now you have your family members sitting in different rooms, and if you want to communicate, you can either shout, let's say your brother or sibling is in the living room and you want to convey something, so you can sit in your room, which is not the living room, and you can shout, saying that, okay, or let's say in my case, I can tell my kid who is sitting in the living room to clean up the place and we can go for dinner, right? So in that case, I'll be passing a message. So I am separate individual, my kid is separate individual. So in that sense, there is this demarcation, and then I will pass a message to the kid saying that please clean up your place and we can have dinner, right? So after cleaning up the place, my kid responds back saying that it's done and then we can have dinner. So there's a communication that's happening between these two individuals, and the communication happens in the form of messages, right? So that's one of the important characteristic of object-oriented programming. So you have these what are called as objects. We'll define this object in a minute, but so assume in my example, you can say you can okay. Was there a question again? Someone raised their hand.
Yeah, sir, I have a question. So do we have any advantages of procedure-oriented programming over OOP?
Oh yeah, so okay, so yeah, I missed out giving an example, right? So uh, one C is a procedural oriented programming language, and an example for object oriented programming is Java, C++, Smalltalk. So Smalltalk is supposed to be a pure object oriented programming language, but anyway, so it depends. So C is very much used in so since it's lower or very close to the what is called as hardware level, right? So you have the assembly language programming, which is right above the hardware. So it's very easy and very fast to compile these assembly languages to bytecode. So eventually, computer can, as you all know, would understand only zeros and ones. So the compilation needs to take place, but the assembly language is supposed to be the fastest because it's very close to the hardware instruction set, right? So then on top of the assembly language, you have these multiple so-called high-level languages. And these high-level languages are further classified under these different programming paradigms. So you have procedural-oriented programming, object-oriented programming, and functional programming. So each one offers different point of view and perspective. So generally, procedure-oriented programming and especially C, right? They are supposed to be very fast because they sit right on top of this assembly language. So in terms of uh, their interaction with the hardware, right? So for example, in C, uh, you can control the memory to a certain extent. So you can ask for certain amount of memory. You can decide. You, in a sense, the programmer can decide when to give back the memory and how much memory to get, and so on, right? So you'll have more fine-grained control over several things, that is including the memory part and when to clean up the memory. And also, since it's pretty close, so and you can also interact with the operating system or the underlying hardware, which is a bit hard to do in Java, right? So for example, you can uh, say, okay, you are you all familiar with the Linux? Oh, okay, anyway, but doesn't. So you'll be using your laptop, right? So you'll have some operating system running on your laptops. So for example, you can run these operating system commands directly from C. So for example, you can say, give me a list of all the directories, and it will run as a operating system command, not as a uh, program that is written within C, right? So you can also do that in Java, but it's something that has been written in Java programming language. So in that sense, the speed is different, right? So C is very fast compared to, or yeah. So over the years, the gap in terms of the speed has reduced because there has been a lot of optimizations that were done in Java also. But even now, C is a lot faster compared to Java. So these are some of the differences. Yeah, but so does that answer your question?
Yeah, sir, it does.
Okay. Okay, so yeah, so getting back to this one, so you'll have so these two individuals. So I was giving the example of me and my kid, right, sitting in different rooms. So we are two different individuals. So you can take this as two different objects, and we are communicating with each other using these messages. So message passing is very central to object-oriented programming, right? So now, how do you pass messages is something that we learn here, and the mechanism to pass messages is through these method calls. Methods, again, like I said, is nothing but a function or a procedure, right? So, so you write a method or you have a method call and you pass these arguments, and then that's how you communicate to the other object. And the other important term here is the property, or which is nothing but the variables in other languages. So you have these variables which are part of the object, right? So there are three names that you can associate with. One is attribute, property, variable, or state. So all these terms mean the same. So we'll be using mostly either property or attributes in this lecture, right? In this lecture and in this course. So get familiar with these three terms. One is the object, the other one is the method, and the third one is the property or the attribute. Okay, so that's and it's also field. Field is also it's synonymous to attribute or variable, right? Okay, now to the definition of object. So what constitutes an object? So at a high level, you will be looking at it in terms of a class. So class. So did you come across sets in mathematics? Was that already taught, or do you already know it from your, say, 11th and 12th? One of you can unmute and let
Yes,
me know.
sir, we have
Yeah, okay.
studied.
Okay, so you know sets, right? So sets, this works in the same way in terms of the class and object relationship. So you have sets and the elements of the set. So let's say you have a set of animals, and the elements of this animal set would now be all the animals, right? So cat, dog, monkey, anything, all these animals would be part or would be the elements of this set. So you all, so you have grouped all of them together because they all have the same characteristics at a high level. So if you look at it at the lower level, they are obviously different, but they all share the same characteristics, right? And that's why you group them together. So here, class is nothing but the name of the set, which is animal, and object is nothing but the elements of the set. So you can say cat is an object, dog is an object, monkey is an object, and animal is the class. So more formally, object is an instance of the class. So you can have multiple different sets, and each set can have different elements in it. And now you can assume object-oriented programming as interactions between these sets, right? So you have, let's say, set of birds, set of animals, and then you have animal kingdom, right, as a class or as a set. So animal kingdom would have animals, birds, and you can have further categories like amphibians and so on. So figure out. Yeah. So that's so class is a more general structure. So you have let's say faculty, for example. So giving one more example. So faculty is a class, and within this faculty set or class, you have multiple different elements who are the faculty members. So say Raghava is a element of that set, or is an instance of faculty class. Vivek is an instance of faculty class, and you have several others. Let's say all the faculty members of AAA Delhi are elements or instances of that class. Right? So that's the other example. Okay, so now I'll move on. Okay, we have one more example here. So you have this car. Treat that as a class. So you can have multiple different cars, right? Like so let's identify car by the number plate. So which is, so say DL, which is Delhi, DL 101, DL 102. Sorry, yeah. What? Is there a question?
Is there any difference between objects and instance?
No. So objects are instances of classes. They are the same. But in object-oriented programming, you call them as objects, but they are instances of classes. Instance of a class. Sorry. Okay, so I'll go on. So let's say in this case, in this example, the class is car, and we can identify the instance or the objects of the car class as by the number plate. So you can say car 101, or car has the number plate 102, and so on. So now car has, or every class will have properties or attributes and methods, right? So methods are used for communication or the message passing, and attributes are used to define the state of the car. That's what we discussed earlier. So so in this example, we have two attributes, which is fuel and max speed. So these attributes change over time. So if you consider the life cycle of the object, so so the life cycle, so the life of object starts when you create the object, and it will run through the point when you exit the program, right? Because like we discussed earlier, in C you can explicitly kill the object, but in Java you cannot do it by yourself. You have to leave it to the programming language environment. So it will take care of deleting the object for you. So until the object gets deleted, the values of the attributes can change, right? And that means the state of the object can change over its life cycle. Right? So these things change, the attributes change, which is also true here, right? When you travel, the fuel gets lower, and when you fill it up, the fuel increases, and same is the max speed is always same, but if you replace max speed with, consider this as speed, then the speed also changes over time, right? And the way to communicate with this particular object is through these methods. So you can have communicate through refuel, get fuel, set speed, and get speed, right? So we'll learn about these get and set after a few slides, but this is one of the examples of a class. Okay, so there are multiple advantages like we just described. Right? So there are multiple advantages in object-oriented programming when you compare it with other paradigms of programming, especially with, say, procedural-oriented programming. So one is that you can keep reusing these objects. So what we mean by that is, let's say you have uh, one object, and you can make that object as a one of the attributes of a different object. So this is the containership, right? So you can keep reusing the entire piece of code in multiple different places. So an object can contain other object also. So let's say in the car example, you want to create a wheel or an engine as a separate class. So there are different classes of, there's an engine, but there are different types of engines, right? So engine is a separate class, wheel is a separate class. So now the car class can hold objects of these different categories. So it can have an instance of engine, or it can have instance of wheel, particular type of wheel, and so on. So in that sense, you can reuse and these objects pretty easily. So the other one is the design advantage. So you can, before you start the coding process itself, the implementation, you can design these classes. So you can take the task, break it up into subtasks, and think about the classes that will handle these different tasks, subtasks, right? So it can lead to better design when you compare to, say, procedure-oriented programming. So at the top level, you will see a bunch of classes and their interactions with each other. So we'll also be drawing some diagrams later on. Not in this lecture, but in this course, we'll be creating a few diagrams that describe these classes and the interactions between them. So we call it as the UML diagrams, which stands for Unified Modeling Language, right? But we'll get to know it later on. Okay. So since there is this kind of so to say abstraction, right? You can look at the code from a higher level. Since that is possible, it's also easy to know what are all the different components that make up this code and how they interact with each other. So if you want to make changes to any particular component, it becomes easier when you go for direct regular procedure-oriented programming. So think of code which is very large, let's say 50,000 lines of code. So it will have many classes, and when you want to make some change, you can easily get to know what are the classes, other class it's interacting with, and you will also get to know the effects that it has, right? So one change can have multiple effects on the entire system. So it's easy to trace those changes. So that's the other advantage. And of course, it's also leads to simplicity, because you are now able to divide your tasks into these classes, separate classes, and the interactions. So those are the advantages. And now, whenever we talk about object-oriented programming, there are certain characteristics that this programming paradigm has, and these are the characteristics, right? So during the course, again, we'll be going over all of them. But in today's lecture, we'll be talking about encapsulation, and to a limited extent, we'll also talk about abstraction, right? But we'll have more about encapsulation in today's lecture. But like I said, we'll be learning about all the other characteristics in the next couple of lectures. Okay, so let's start with abstraction. Right? So there are two characteristics among this list, which are slightly related, but they are a bit different as well. So one is abstraction, the other one is the encapsulation. So abstraction, okay, there are still people here. So abstraction, as the term says, so you will be looking at things from the higher level, so you will be looking at the overall interactions. So let's say if we take the example of this picture here, right? So whenever you see the car, or when you sit in the car, you are only worried about or you will only be thinking about driving the car or going to a particular destination, and by driving the car, right? So you will not be worried about how the engine works or how the brakes work. So the internal mechanism, so you're not much concerned about the internal mechanism. So whatever is the internal mechanism, once you sit in the car, you will only be thinking about the driving part and reaching the destination, right? So there's a lot of information that is hidden, which is not required for you. So if someone is enthusiastic about how the components work, then they can get to know it. But it is not required for everyone to get to know it, right? To not drive the car. So you will be looking at it from a higher level. So that's the abstraction, right? So going back to the apartments and the building example. So when you look at it, let's say from bird's eye point of view, let's say you have a helicopter, you are flying over to Payton. So you'll only be looking at it from you'll only be seeing multiple different buildings. And maybe if you go a little higher, so you'll only be seeing the tallest building, maybe among the multiple buildings that we have. So as you go higher and higher, you'll only be seeing the top level details, the higher level details. So for many tasks, this level of detail is sufficient, right? So for example, in the car example, if you want to just go to a different destination from one destination to the other, it's sufficient if you know how to drive a car. So you don't need to know how, let's say, different parts are working, right? So as you go lower and lower, you will get to know more details. So for example, if you go to inside the building, you will get to know that there are multiple apartments. And if you go inside the apartment, you will get to know that there are multiple different rooms in the apartment. So those are different levels of abstraction, as it is called, right? So that's about abstraction. Is there so if you have a question, please unmute and ask, because it's hard to check the messages. Can an object of a particular data type have so root of the same data? Okay, so maybe so an object will have a data type, and the data type is that of the class. So in going back to the example that I said, which is the animal set. So you have the data type of all the elements of the animal set is nothing but animal, right? So so if you say what is the type of monkey, it's animal, and the type of dog is animal. So that's the data type. Now within this class, there can be attributes. There can be attributes such as number of legs, number of hands. Does it have let's say ears? So for example, snakes don't have ears, right? So does it have eyes? So these are different attributes of the animal class. So these attributes can be again of different data types. So they can be integers, floating point numbers, strings, or they can be other data types also. So for example, they can be data types of, as I said earlier, so you can have objects within the other objects. So they can be some sort of containership as well. So one of the data types can be, let's say, I don't know, amphibian. I'm just giving an example. Right? So you have, along with infloat string, the other data type that one of the attributes can have is an amphibian, which is itself a class. But we'll get to know this later on. So I don't know if that answer your question. Okay.
Yes, sir.
Okay, so let's get to the other characteristic, which is the encapsulation. Right? So again, if you look at, okay, let me just. So if you look at just the term encapsulation, right? Encapsulation is nothing but wrapping, a wrapper. So assume that you are buying a gift, and inside, so you are planning to gift a coffee mug, for example. So you have the coffee mug, and you are planning to, since it's a gift, you are going to gift wrap it. So there will be a wrapper on top of the coffee mug. So only you would know. So you, in a sense, whoever has purchased it or created it, would know what is inside it. But others who are looking at it would only see the wrapper, right? So that is nothing but the encapsulation. So you are wrapping up the internals with some sort of layer, and out people who are outside of it, or anyone who is outside of this wrapper, cannot know what is inside the wrapper.
Excuse me, sir.
Yes.
Can you clearly differentiate between encapsulation and abstraction? Like,
Yeah. So let me first go over encapsulation, and then I'll talk about the differences. Right. Okay. So like I said, encapsulation is nothing but a wrapper, a simple wrapper. So an example is given here. So we can treat the contents as a black box, right? So black box is nothing but you cannot see what is inside that box. So all you can see is the interaction mechanism. So for example, you take any electronic device, let's say a phone or a laptop, right? So let's stick to phone. So whenever you look at phone, you cannot see what is inside the phone. So all you can see is ways of interacting with the phone, which is through the touchpad and the plug points, right? So you have these plug points which you can use to charge the phone, for example, or you can put in your USB or the earphone, right? So these are all ways of interacting with the phone, but you wouldn't know what is inside the phone. So you are because you don't need to know. So you you don't know what are the circuits inside it, or what are the other electronic equipment that was used to create the phone, and so on, right? So there is a wrapper on top of the phone, and that is what is called as encapsulation. So a simple wrapper. So that is what is shown in this figure, right? So you have the black box, which is a wrapper. So inside the black box or the wrapper, you have these methods and the data. So this is nothing but the class. And now you are exposing certain interaction points, which is shown here with these red dots. Right? So these are the interaction points, and whoever is outside of this wrapper, so here we call them as clients. So these clients can only interact with this black box using these interaction points. And these interaction points are generally the methods. So like I said earlier, so you can use these methods for passing these messages, right? So for example, if you want to, there's a faculty class and a student class, and a course class. So if you want to connect these classes or pass some message, so you can say that faculty is advising student 1 and student 2. So that's the link between these two, and that's also how the way to interact with this student class. Our student is registered in say 2 courses. So that's again an interaction mechanism between course and the student, right? So that's so like yeah. So is this clear? So it's like a black box, and it's simple. It's a simple wrapper. So so there are next couple of slides which talk about encapsulation, and then we can get back to abstraction. So this is something where there is no encapsulation, right? In that sense, so you can interact with, so this is not a black box. So this is a simple list of data types or variables and the methods. So now assume that this is your program, and there are multiple different objects, or even if you take procedural-oriented program, there are multiple different functions here. Let's say 10 different functions. So now these functions can interact with any one of them as they please. So they can call any method, they can change the value of any of these methods. So there is no yeah, can you all mute? Okay. Yes. So there are different, so there is no control on who is interacting with these internals of the class. So anyone can change the data type or the anyone can call the methods. So there is no control over it, and that is what encapsulation provides. Right? So now this is another example. So if you remove the cover of the car, this is how it looks. So you will get to know the internals, and anyone can directly go and tinker with any of these internals. Right? There is no control over it. But if you have a cover on top of it, there are certain interaction points, and you can only interact with this car or with this object through those interaction points. So which is like starting the car. So there's a specific way to start the car, and you can only do in that way. And there's a specific way to put on the brakes or accelerate, and you can do it only in those ways, right? So you cannot tinker with the internals of the car. So now assume, okay, this is the same example, but with the encapsulation. So now assume that there is a wrapper on top of these variables and functions. And there is also, whenever you have wrapper, you should always define the interaction points or the interaction mechanisms. So there is also an interaction mechanism, which is here we are calling it as interface methods. So we'll be learning about interfaces later on. But assume that this is just a way to interact with this class, right? So now we have these methods, and so now all the different functions in your program or the objects, they can only interact using these interaction mechanisms. So they cannot directly, for example, change the value of the data. They cannot change the value of the name. So these are protected from the outside influence, so to say, right? So we'll again discuss more about these advantages in the next few slides. But this is about encapsulation, right? You can, a simple wrapper over methods or anything. So you can have a set of a bunch of variables, and you can have a wrapper on top of it. Or you can have a bunch of methods, and you can have a wrapper on top of it. So this having a wrapper is nothing but encapsulation, right? Okay, maybe, okay, so why don't I go over this as well? Because that also talks about encapsulation, right? So let me complete the entire encapsulation, and then we can discuss the differences. Okay, so once you encapsulate or create a wrapper on top of certain variables and methods, there has to be some way to, for clients or people or procedures outside of it to interact with this wrapper. So these visibility modifiers help with these interactions. Right? So there are two types of visibility modifiers. One is the public, and the other one is called private. And these visibility modifiers can be applied to both the variables, which are nothing but the attributes, and the methods. So if you say something is private, then that means they are visible only within the wrapper. Right? No one outside of the wrapper can see these variables or methods. So if you say one variable is private, then the clients cannot see the variable outside of the wrapper. But if you say something is public, then anyone outside of the wrapper can also see these public variables or methods. So that is the difference between private and public. So this is within the wrapper, and public variables and methods are visible outside of the wrapper as well. Okay, so let us go over these four values. So if you have variables that are public, then so it violates the encapsulation because it is now visible outside of the wrapper as well. And in object-oriented programming, you are not supposed to directly change the values of the variables. So you are supposed to change it through the messages, right? So there has to be a message requesting the object to change the value, and then it will change the value. So never interact with the variables directly. So that's why it's supposed to violate encapsulation. The second one is the private variables. So that will enforce the encapsulation because now clients cannot directly change the values of the variables. So that's why it's supposed to be private, or it will enforce the encapsulation. Okay. So for the methods, so if the methods are public, then the clients can use those methods, and that is how they can pass the messages also. So for example, if you want to change the name of a person, so there's an employee class, and someone wants to change the name of the person. So you send a message through this method. So let's say there's a method by the name set name or change name. So you can use one of these methods, pass in the value that you want to change. So let's say the name of the employee is John, and you want to change it to Mike. So you can call this method called setName and pass on the value of Mike to the object that to the employee object. So now the employee object would receive this message. So there's a request to change the name of the employee, and hence it will go ahead and then it can change the name of the employee. So that depends on the object, right? So if the employee object doesn't want to, for example, change the name of the employee, then it wouldn't do so. So there is an amount of control that comes with the encapsulation, which is one of the advantages of encapsulation. So now the private method.
Hello. Nanavati Hospital aa rahe ho. Leelavati Hospital ja rahe ho.
So please have this on the side, I guess. So please mute yourself if you're not asking any questions, right? So it doesn't disturb everyone. Okay, so the last category is private methods. So if you have private methods, then it is very similar to the private variables, meaning that they are only visible within the wrapper or the encapsulated module. Right? So you cannot, no, the clients cannot see these methods, and they can only be used within this wrapper. That means by other methods. We'll see these examples in the next couple of slides. So that's about the two visibility modifiers. You have public and private. And as I said before, private, all the private variables or methods, they are visible only within the wrapper, and public ones are visible even outside the wrapper. Okay. So you have, so depending on this private and public variables and methods, you have two types of methods. One is called accessors and the other one is called mutators. So mutators are the ones that can change the values. Okay. So, and as the name says, accessors, you can only access the values. So these are read-only methods, and mutators are write. So you can write into those attributes using these mutators. So let's say some of the attributes or the instance data. So it's private. So the only way the clients can now interact with these private attributes is through the methods, right? Through the public methods. So we can use these public methods and make changes to the attributes. So that's why it's important to have both the accessors and the mutators. So you can, if you want to read the value, so if you want to read the value of the fuel, so going back to the car example, so car had two attributes, right? One is the fuel and the other one is the speed. So at any particular point in time over the life cycle of that object, if you want to know how much fuel does the car have or what is the current speed of the car, you need to have a mechanism to get those values, because you cannot access the instances directly, right? So the only way to, or sorry, not the instances, but the attributes of the instance or the instance data directly. So there has to be a method that you can use to read these values, or if you want to change them, you can change them using these methods. So there is a naming convention. If you can use this get followed by the name of the variable. So you can say get fuel, for example. Get fuel would return the current value of the fuel, and set fuel would write the value, would be changing the value of the fuel. So for example, let's say the current value of the fuel is I don't know, like 3 liters, right? So now if you want to say set fuel to 2 liters, so it will go and change the value of the fuel variable or that. But the convention is to use this get for accessors and set for the mutators. And that's why they are sometimes called as getters and setters. So getters are for reading the values and setters are for writing the values. So is that clear? Okay, there's a follow-up question here. So here there can be a question. So if we are talking about restricting the values of the fields, why do you want to set it, right? Again, so okay, I need to again figure this out. So don't write. How can let me? No. So we cannot, so if you want to interact between certain objects, there has to be a way to interact through these methods, right? Because you cannot directly change the values of the attributes. So that's why these setters are also important. So whenever, let's say there's a program that's calculating the mileage of the different cars. So if you want to calculate the mileage, you need to know the fuel level at the different stages, the distance that it has traveled, and so on, right? At least these two values. So if someone is calculating the mileage, it needs to ping or ask the car class, say how much fuel do you currently have, or and how much distance did you travel, and so on. And based on these values, you can calculate the mileage. So unless it knows certain values, and the only way to know these values is through these access and mutators. So that's why it's important to have these methods. And even if you want to restrict it, uh, restrict the fields, or which is nothing but the attributes, you need to open it up in a certain controlled way.
Hello, sir. I think someone outsider has joined. The participant name is Munna. You could just remove him from the meeting.
Great. Thanks. Let's see. Okay, seems like they disconnected. But how is this? So that's why I enabled the registration option, so that only people with TripID accounts can register and then join.
Yes, sir.
Sir,
But I just
it could
checked. I
be
think
someone from Triple ITD itself who has changed his name.
Okay, yeah, then we can't do much, I guess. But I'll look into it, in the sense that how can we at least stop these, like there's someone who is scribbling on the slides, right? So I don't want others to scribble on these slides. So I'll check that later on. So one of the main reasons why I switched over to Zoom. So earlier I was using Google Meet. So the reason I switched over to Zoom is, so I was told that the file size of Zoom when we record the lectures is smaller compared to the Meet. And whenever you want to, if you are recording, which is the case now, and if you want to download these lectures onto your local laptop or desktop, it will become a lot more easier. So this is useful for students with lower bandwidth, right? So that's the reason I switched over. So let's see how it goes. And yeah, I'm okay with switching back to Google Meet as well if this doesn't work out well. Yeah, this is Zoom Premium. So we have the licensed version. Okay, so let me go on. Okay, yeah, this talks about the usage of mutators, right? So if you have some restrictions in terms of the encapsulation and the public and the private modifiers, so you can also place some restrictions. So you can say that whenever there is a change request, so you want to change the name, so you can say that you will only change the name if the first character starts with a alphabet, right? And there should be, let's say if it's a password and you want to change the password, so you can place more restrictions. You can say that the length of the password should be at least 8 characters, and you should have at least two digits, and one of the characters should be capital letter. So you can place all these restrictions within the setter. So that is one of the advantages that encapsulation and the public and private modifiers offer, right? So you can control the way in which someone is reading and writing into your instance data or the attributes. Okay, so yeah, this is the other advantage. So let's say you are setting the say the age of a person. So let's say there's a teenager class and you are setting the age of the person. So you want to make sure that the age is between 13 and 19. So if you get a request of set age and the age is, let's say, 10. So you can reject that. Right? So these are the advantages. You can have more fine-grained control on first who is accessing the data, and second, what should be the values that are getting changed and accessed. Okay. So okay, we'll go over this slide, and then I think we have the break here. So after this slide, we can also go over the questions, right? Whatever questions you have. Okay, so this talks about the differences in procedural programming and object-oriented programming in terms of the interaction between the data and the functions. Right? So here, let's say in procedural-oriented programming, you have multiple functions, and each function can have some local variables. And if one function wants to interact with the other function, the only way to do it is through these global variables, right? Shared global variables. So you can, one function can change the value, and the other function now can read the value from the global variable. So that's how they can interact with each other. But in the case of object-oriented programming, you have these encapsulated objects, so to say, and the way to interact with them is through these messages. So you pass the messages, and like I said earlier, you pass the messages by calling a function. So that is nothing but the message passing. Right? So you have these functions, and you can call the function of this object, which in turn can call the function of this object, and so on. So they can interact in a controlled way. And if you look at it from a high level, right, which is in the form of these diagrams, the interaction between these objects is much more it's more well defined, and it's more clear. So when you look at it, it's clear that these two objects are interacting, and you will also get to know what is the functions, or what are the public modifiers, access modifiers here, right? So if it is interacting with, let's say it has 10 functions, and if it's interacting with only 2 of them, that means those 2 are the public functions or the methods. The others can be private ones. So that's why there is no way to interact with these private ones. But in this case, the interaction can be all over the place, and it's very hard to know who is interacting with the other person. So once you change something, it will become harder to maintain, and so on. So that is one of the main advantages of object-oriented programming. Okay. Yeah, I don't know why. So people in abstraction, sorry, in encapsulation, you are only talking about the wrapper. So I think that is a good. Yeah, this one. So you'll only be talking about the wrapper, and you're not discussing about which one to wrap or how to wrap. Right? So there can be multiple different. Say you can only have a wrapper on top of the data items, or just the methods. But in abstraction, you will be talking about the different levels of looking at the details. So just to give an example, right? You can have 2 classes, so that means 2 wrappers, and then you can wrap again on top of it. So let's say going back to the animal kingdom example. So you have the animal kingdom, and then you have animal, bird, let's say amphibians. So these 3 categories. Right? So each of them is encapsulated. So you have the encapsulation over, say, birds. But let's say, for the sake of the example, you don't have an encapsulation over the animals. So you have a list of animals, so dog, cat, and all, but they are not part of any encapsulation whatsoever. So abstraction can exist without encapsulation as well. So you will only be looking at, now if you look at animal kingdom at the higher level, so you will only be seeing just the animal kingdom and nothing else. So you will not know that inside animal kingdom there are birds, animals, and amphibians. But if you go one level lower, you will get to know that, okay, now there are amphibians and birds as well, and animals as well. And if you go one level lower, for example, if you go within the animal class or the set, so you'll get to know that, okay, animal, there are certain attributes of all these animals, which is feet, the number of feet that they have, the eyes that they have, or the wings, number of wings, and so on. So the other analogy is the building example. So if you have the bird's eye view or the helicopter view of Triple Italy, so you'll only see the tallest building. So that's the highest level of abstraction, right? So at that, from that level, you'll only be seeing the building, tallest building. But if you come a bit lower, then you can see all the other buildings as well. So let's say if there are 10 buildings, you can see all the 10 buildings. But if you go a bit lower, which is you are entering now into one of the buildings, then you can see all the people inside the building as well as all the rooms. Now, if you enter the room, which is the lowest level of abstraction here, you can see the internal workings, right? So you can see that there are multiple objects in the room, and there are multiple people sitting in the room. So abstraction is at multiple different levels. So the idea behind abstraction is to hide these unnecessary details and expose only the required details. So encapsulation is one. Encapsulation helps you to get this abstraction. So going by the analogy of the example of this building, right? So first you encapsulate the people and the objects in one room. So the encapsulation here is the room. Now you go one level higher, then you can know that now you would have the encapsulation of the apartment. Right. So if you go one level higher, then it's the building. And maybe if you go one level higher, then it's the organization, which is triple. So you have multiple different levels of abstraction, and each abstraction level is differentiated or distinguished from the other abstraction level through these encapsulation mechanisms. Right? Is that clear? Or do you have any questions? So here, right, taking this example.
Excuse me, sir.
Yeah.
Sir, after you're complete with the material that you need to present, can you tell about the course outline? That is what all you'll be covering in this course.
Sure. Okay. Yeah. So, so that part would be in the course description, right? Which should be available to you. So we have the week-wise lectures, week-wise topic descriptions in the course description. So you should be, so you should have access to the course description, right? So in terms of the lectures, yeah, we'll, so I can give a high-level overview. So we'll be talking about these different characteristics of the class, of the object-oriented programming. So next class we'll be talking about, let's say, what are classes and objects, how do you create them, and then we talk about inheritance, polymorphism. Then we talk about these constructors, say method overloading, overriding, and then you have the design aspects. So how do you design the classes and the objects, and how do you show the interactions among them? So that is through the UML diagrams. So we learn about UML diagrams. We then have threads, multi-threading, and then we have design patterns. So what are the design solutions, so to say? So they'll always be common design problems, and there are some solutions to it. So what are the different solutions that you can use while designing your classes? So we'll be talking about all these different things, but you can get more detailed descriptions from the course description file. Oh, it's already 350. Okay, great. So are there any other questions? I think I only covered half the lecture.
Sir, will you be taking attendance in this course?
No, I don't think so. I don't. Yeah, I didn't actually check with the other instructor. But yeah, I don't think so. But I'll check with the other instructor, Vivek, and then I'll get back to you. But yeah, I don't think there's a way to take attendance. Yeah. So are there any other questions before I move on? So please do fill up this survey. So you can do it during the class, so just now or even after the class as well. Okay, so if you don't have any other questions, I'll move on to the next part of the lecture. Right? So in the next few slides, we'll only be looking at certain examples and how we can use these encapsulation to capture, or the classes to capture these or model these problems, right? So the first problem is you have two dice which can have any number of sides. So that will be specified by the user or by us. And the idea is you need to report, let's say you also throw it certain number of times. So you should report the number of times in which both the dice have showed 1. So which is called as snake eyes. I don't know the reason, but yeah. So I assume so since so both the dice, the idea is both the dice should show 1, right? And we should count the number of times that it has showed 1. So this is the main method. So this is the dice 1, the number of sides that dice 1 has. So it has 6 sides. So whenever it has 6 sides, the assumption is that it goes from 1 to 6. And dice 2 has 13 sides. So again, it will go from 1 to 13. Right? And this is the number of times the dice has been rolled or thrown. So it has been rolled 100 times. And now we need to count the number of times both the dice have showed 1. Right? So that's the problem. So if we do it using procedural style, so which means we please mute yourself. So which means we'll be writing a few functions, and then the functions would be interacting with each other. So there are two functions here. One is the number of snake eyes. So it has the 2 sides plus the number of throws. And the other one is the roll. So whenever a dice is rolled, the idea is that we'll get a number at random or the side at random, right? So in order to simulate that, we use the random number generator. So it will take in the number of faces or the sides as the upper limit, and it can generate any number between say 1 and the number of faces. So if the number of faces is 6, it will generate a number between 1 and 6. So that's the idea at least. So so in the example we said there will be 100 throws. So we have a loop. It will go on from 0 to 99, and it will roll 100 times, and it will simply count the number of times each dice has showed 1, and the count is written. So this is what the number of snake eyes is, right? So this is how we would have done it in procedural style. But in object-oriented style, we first focus on the mechanism to first categorize these different actors or the objects first. So here, the main object here is the dice. Right? And dice, then once we identify the classes, so we need to identify the attributes and the mechanisms to interact with the attributes, which is the methods. So here the dice would have certain characteristics. One is the number of sides that it has, and the maximum number of faces. Sorry, is that question? Okay, so we have this. We need to think about the state and the behavior. State is nothing but the attributes or the variables, and behavior is nothing but the methods that we use to interact with the state. Right? Okay, so let's so this is a different example, but we have the attributes here and then the methods. So it's a simple way to picturize the class. Right? So we get to the dice class, which is what we are interested in. So there are two attributes here. One is the face value and the number of faces. So whenever you roll a dice, some value would show up. That is the face value. And the total number of faces is the number of sides. So if it has, let's say, 6 sides, the number of faces would be 6. And the way to change this would be through these methods. So it has the roll method, and then it has the setters and getters. So setter and getter setter is for the writing part, and getter is for the reading part. Are there any questions? Or? Okay, so let me go on. So you have the dice class, and then we also have seen the modifiers, right? The visibility modifiers. So you have the private here. So we'll discuss the final later on, but final is a mechanism to create a constant. So if you say something is a constant or a final value, then you cannot change it over the life cycle of the object. So you can only do it at the time of the creation. Once you do it at the time of creation, then you cannot change it. So which is how it should be, right? So for this case, a dice will have a fixed number of sides or faces. So it cannot change over the life cycle or its lifetime.
Sir,
So yeah.
sir, but like if we define a variable as final and we do not assign its value in the constructor, but we want to assign it during.
Okay. Yeah. Go on.
Yeah, so if we define a variable as final and we do not assign it a value in a constructor, so can we assign it afterwards, like in some other function?
No, as far as I know, you can only do it at the time of the creation, which is what the constructor is for. So you should do it at the time of in the constructor. So I don't because if you are doing it at some other point of time, right? Then you can. It's like saying you can change it at any point during the life cycle of the object. So you should do it whenever the object is born, so to say. So whenever the object is born, which is whenever it got constructed, you should instantiate it, or you should specify the value of the constant, and later on you cannot change it.
Thank you, sir.
Okay. So this is fixed, the num phase is fixed, and then you have the private value of phase, which is phase value. So that means you cannot, these two attributes are not visible outside of the dice class, which is the encapsulation here, right? So in order to interact with these two, you need public methods, and there are certain public methods that are defined here. One is what is called as constructor. We'll get to know it in the next classes, but constructor is a mechanism to build an object or construct an object, as the name says.
Excuse me, sir.
Yeah.
Sir, why are we not using const in place of final?
Const in place of final. Huh.
Yeah, we can.
Not even sure if
we can use it, right?
Does Java has const?
Yeah, I guess it has.
Okay, I'm not sure. So, okay, let me look it up and then I'll get back to you. So I can either post it on the classroom or I can answer in the next class. But I am not sure if it has a const. I thought it's more of a C++ or C thing. But yeah, let me check it. And then I'll get back to you.
Okay, sure.
Okay, yeah, thanks. So, okay, the mechanism to interact with these attributes is through the public methods, and which are also called as the messages, right? So you have the setter here, and you are in some ways passing a message to this object, asking it to change the value. And we can also see the advantage of this one, the encapsulation here, right? So you're controlling the way in which the value gets changed. So if the value is less than the number of phases, so let's say the number of phases is 6, and if someone is trying to set the value to -1, it's not a valid value. So you do not consider those kinds of requests. So you'll have more fine-grained control of the reading part as well as the writing part. So it's the same same code, but it has been encapsulated in the form of a class, right? So you have the roll method and you have the set phase method. Okay, we already discussed this. So going ahead, we also have the mechanism to read and write into the number of phases, because this is not a constant. So you can, for constants, you can only read them. So there's only a getter. But for other attributes, you can have a getter and setter, so that there's a way to read and write them. And the other new method here is the toString. So you can use the toString, which is a Okay, we'll learn more about this later on, but it's a built-in method, right? So it's available to all the classes, and you can override it. So we'll again learn these terms later on. But the purpose of toString method is to, as the name says, so it will take the values of or the attributes of the class, and it will convert them to strings. And this is mainly useful when if you want to print out the object. So if you say print dice1, for example, it will print out the values of all the attributes. So that's how you are printing the number of faces, and the plus here indicates the concatenation. Okay, let me quickly go over this example, and then I can stop. So we went over the period
Excuse me,
slightly
sir.
quickly. Yeah, right. Yeah, tell me. Yeah, what's the question?
So if we try to print the object, will it by default call the toString function, or we need to explicitly call it?
No, it will call it by default. So if you define the toString, then you can also, the advantage with defining the toString is you can now put in the content that you want to be displayed. So there's, like I said, there's already a default toString, but it will print a random value, right? Like it will print a hash code, for example, hash code of all the attributes, which you do not want. So this is a more customized version of toString where you are printing you have the string plus is for the concatenation. So you're concatenating the integer to the string, and it will print a nice string so that you can read it and understand it. So that's the advantage of toString. Okay, now you have the main method, which
Sir,
is,
hello.
yeah.
In the previous slide, why were we using final if it's anyways private? Because it won't be accessible to the client, will it?
It is not, but even you cannot change it even within. So, for example, so there's a toString. So let's say you have one more, say snake eyes, right? Number of snake eyes. So here, if you want to change it, you should not be able to change it.
Okay,
So the only way or the only time when you can assign value to it is at the time of the construction.
Okay,
so private values are visible within the encapsulated part, right? So it's visible within this class. But yeah, you shouldn't be able to change it. Okay, so now you have the snake eyes method, and we are creating two dice, dice 1 and dice 2, and we are also specifying the sides. So we'll get to know this syntax later on, but this is a way to create the dice. Okay? And now you are again going over it 100 times or whatever is the number of throws. Let's say it's 100. This is a way to pass the message or call the object. You are using the dot operator and calling the method, right? And if the method has any arguments, you pass in the arguments. And this is the way to call one of the getters. So this is a getter. I think there should be a the parenthesis here, which is missing. So you put in the parenthesis, which is similar to this one, and call the method. And if it returns 1, then you are incrementing the count. So in that way, you are just counting the number of snake eyes. So this is the object-oriented version where you have the clear separation of the procedures, and then you have encapsulated the entire dice functionality in the dice class. So now you know that if you are interacting with the dice, then you know, so first thing is it's more clear, and secondly you would know that what are the ways in which to interact with this dice class. That is through the public method, right? Okay. So this is again an extended example. So there is a different example where they are taking 7 sides and 34 sides and rolling it a few times and printing the value of the two faces. So I'll skip it quickly. So this is a pictorial representation of the objects. So you have dice 1, and within there are 2 attributes to it, right? So you display the 2 attributes. So this is called the state of the object. So now the state of dice 1 is that face value has the value 5 and num faces has the value 6, and this is the state of dice 2. Right? And we already discussed about toString. So toString is, like I said earlier, you can use this to display the state of the objects or print the state of the objects in a more user-friendly way. So there's one more example which is on coin flips. So I'll skip this part because we are running out of time. But you can go over this example again, which is, so the idea here is you flip 2 coins, and if the, and so the number of heads should be 3 times, should come 3 times in a row. So there should be, it should come consecutively heads thrice, right? And whenever whichever coin has that, that coin is the winner. So we are again, the main class here is the coin class, and there we are representing the heads by 0 and tails by 1. And again, since we don't change these values, we are making it final, right? So yeah, that's how it is, very similar to whatever we have seen in the other example, snake eyes example, right?